Hello and welcome back to another tutorial. In today's episode, we're going to be covering advanced blocks and items, which includes custom block and item classes, custom models and render layers, custom block state properties, tags, foods and fuels, and recipes. And since I'm covering a variety of topics in this episode, you can skip to sections that suit you. So if you don't care about custom models, you can skip straight to the recipes section, and vice versa. And this video is more like an explanation filler video, since all of these topics are too small to have their own. So I'm going to start off with custom item. In here, we registered our example item over here with our JSON name example item, and we've given it item properties. But the only item property we've actually given it is the creative tab. And if you go after here and press dot, and if you don't see this menu, you can press Control space, you can see all the different things that you can do to your item. So craft remainder, so what happens if you craft the item. So for example, for a water bucket, you'd leave the bucket in the crafting menu after it's been crafted. The default durability and durability, whether the item is fire resistant, we can make it a food, which I'll discuss later. You can give it a rarity, so to do that you do dot rarity and then rarity dot, and then the name of your rarity, so common, epic, rare, or uncommon. You can set no repair, and use stacks to set the maximum size of the stack. So for example, an ender pearl would be 16, or for something that's non-stackable like a sword, you want to set the stacks to 1. And you can chain these on, so for example, I want to make a fire resistant item which has a stack size of 12. And you can keep adding these on to create more things to your item. But what if you want your item to have even more functionality? Perhaps functionality that isn't included in Minecraft by default. Well, to do that, we can create a custom item class. So in our com.cypher.tutorial mod package, we're going to right click and create a new package called item. And in here, we're going to put all of our custom item classes. So let's right click on it and go to new class and create our example item class. And our example items are going to extend item. And we can press Ctrl-Shift-O to import net.minecraft.world.item.item. Then we can hover over this and add our constructor. And if you want, you can rename this to properties and the same down here. And this is our base item class. So back in our item init, we can change this new item over here to a new example item and press Ctrl-Shift-O to import that. And now we can add functionality to our item. So in example item, we can go down a bit and press Control space. And over here, we can see all the methods that we can override. So if I make this larger, you can do some stuff. You can do can attack block, append hover text, which is the tooltip. You can say if it can fit inside containers, so if you can put it inside like a chest or something, if you can equip it, and other stuff. There's loads that you can override here, and I'm not going to cover them, but a couple useful ones include finish using item, that's for something like a food, once you finish using it. Append hover text, which is the tooltip, and you have a bunch of stuff to do with sounds over here, and much, much more. I'm going to press Control space and override use. And this function will be run when a player uses an item. So if we hold Control and click on use, we can see what it does by default. And this will just check if it's edible and then eat it. Otherwise, it will just pass the use. And you can see that here we have a consume, so the item has been used, a fail, and a pass. Let's rename the level to world, since that's our world, our player to player, and the interaction hand to hand. And then change the things below accordingly, just so that we understand what we're actually writing. Let's delete the to-do, and in here, I'm just going to write some example code, but obviously this can be whatever you want. I'm going to first check if the world is client side. And many functions in the item class will often be run twice, once on the server and once on the client. And it's really important to differentiate between the two. So we're just going to make sure that the world isn't on the client and that we're on the server. So let's add an exclamation mark here. Let's do system.out.print line, so just print something to the console, and we're going to print player.getName.getString, so the name of our player, plus has used item, with hand.name. And this will either be main hand or offhand. So now when we run the game and pick up our example item and then right click, you can see in the console that we have dev used item with hand main hand. And if we switch to our offhand, you can see that it says offhand. Now let's talk about more advanced blocks. So let's go into our block init, and over here we have two things. We have our actual block itself and the item for that block. And for that block item, you can use the same properties as we used in the item. So we have a .tab, and here we have a food, rarity, durability, craft remainder, fire resistant, etc. And this item properties describes how a block behaves as an item, and the block behavior describes how the block behaves when it's placed down. So from last episode you can see that we're using a material which is metal, and this just defines a bunch of basic stuff, and you can see there's a bunch of different materials over here. The material color is what shows up on the map. Our block is purple, so I put it to color purple. And if you hold Control and open material color, you can see all of these codes, which are the integer codes for the color, if you want to check what they are before you start the game. The strength defines the hardness and blast resistance. You might notice that there's two different strength functions. One of them has two values, one of them takes one. The one that takes one value just passes that one value into two values. So if you just have 3.0, you're setting both the hardness and the blast resistance to 3.0. But if you want them to be different, you can do something like this, which is going to set the hardness to 3 and the blast resistance to 2. And if you want to know what the default values are for the Minecraft blocks, you can look it up on Google. The sound defines the sound for the block. So you can do sound type dot and then all of these different sounds that our blocks can be. Then we have required correct tool for drops, which won't call the loot table unless it's using the correct tool. We also have .air, which makes it equal to air, dynamic shape, which makes it not a full block, and emissive rendering, which will render a block despite its light level at full brightness, so something like a magma block. And this takes a state predicate, so to do that, we can create a new predicate for which we're going to pass in the state, the getter, and the position, and then an arrow like so with a bracket. And then this needs to return a boolean. So if I just return true here, it's always going to use emissive rendering, or I can decide it based on the state, so given any properties inside the block, or given the position. So I can do return pos.getX is equal to 50. So this will just set it to emissive rendering only if the X position of the block is equal to 50. We can also define if it's a redstone conductor, which also takes a state predicate. If it will suffocate you, also taking a state predicate. If you can spawn on that block. Jump factor, which will multiply your jump height when you're standing on the block. So something like soul sand will have a low jump factor below 1, which makes your jump height smaller. No collision makes it so that you can't collide with it. No drops removes all the drops. Random ticks will randomly tick that block. And light level will take an int function which defines the light level of that block. So this is going to be given a state, and we're going to output a light level. Say 4, which always gives you a light level of 4, and we can change this 4 based on things inside the state if you would like to. So now our block will render emissively if the X position is 50, and it will emit a light level of 4. So if we run the game and set the time to night, we can see that it emits a very small light level of 4. So you can see there's a very small circle around it. You might not be able to see this because of the YouTube compression, but it is there. And if we place it in a block where X is 50, you can see that it will always render at full brightness, no matter what the light level is. Now let's make a custom class for the block. And this is very similar to the item. We're going to create a new package in com.cy4.tutorialmod called .block. Into here we're going to create a new class called example block, and this is going to extend block, and let's press Ctrl+Shift+O to import this world.level.block.block. Hover over this, add a constructor, rename the properties to properties, and replace it down here as well. And now we've created a basic block class. Back in our block init, we can change this new block to a new example block, press Ctrl+Shift+O to import, and there we go. Now in our example block we can overwrite methods, so we can press Ctrl space to see all the possible methods. And once again there's loads of methods that you can use, and most of these are going to be self-explanatory. If you need a specific one, you can join the Discord and ask, and someone should be able to help you. I'm once again going to override the use function, but this time this is when a block is clicked. So let's set the block state to be called state, the level to world, block pos to pos, the player to player, interaction hand to hand, and the block hit result to result. And let's rename the stuff down here accordingly. And this is going to give an error because this command is deprecated, so we're just going to hover over that and make sure to suppress it. And if we hold Control and click on use, we can see that by default it returns an interaction result pass. So what we're going to do, we're going to check if world.isClientSide, and once again we want to add an exclamation mark to make sure that we are on the server, not the client. We're going to check if player.getItemInHand, and this is going to give us the item stack that the player is holding, .getItem.equals, and then we're going to do items.diamond. So that's going to check if the item the player is holding is a diamond. And if it is, we're going to system.out.println. And once again, we're going to get the name of the player. So player.getName.getString interacted with block at pos plus pos.toShortString, which will just give us the string for the position, and space using a diamond. So that's just going to print a message telling the user that the player has interacted with the block. And if that happens, we're going to return interaction result.consume. And it's important to return the correct interaction result, otherwise you might get some bugs. Consume will say that something has happened, and the action has had some effect onto the world. And if we start the game, we can see that if we right-click the block, then nothing happens and our hand doesn't move. But if we hold the diamond and right-click, you can see that in the chat it says dev interacted with block at the position of the block using a diamond. This video is sponsored by MTXServe. MTXServe provide game server hosting for games such as Minecraft, Rust, and Valheim. The servers are incredibly performant with a AMD Ryzen 5800X and unlimited SSD storage space as well as DDoS protection. And all of this for a pretty low price. Use code CY4 to get 5% off your server today. Next, we're going to talk about how to make this block have a custom model. So to do that, we're going to download a 3D modeling software called Blockbench. So let's go to blockbench.net, and you can use the web application, but I'm just going to download it. And I'm going to select Windows, but you can select your operating system, and I'm going to download the installer. And once it's downloaded, let's run the installer, and this is going to install Blockbench. And once it's finished, it will open Blockbench, and now we can create our model. And you can select your keybind preference. I'm going to select the default mouse keybinds, and then we can create a model. And you can see there's lots of different things, and we'll be using Blockbench a lot in lots of different tutorials. But we're going to create a Java block/item. File name will be example_block. It will have no parent model, and we'll just keep our texture size. Let's click confirm, and you can see that we have our model. I'm holding down on the middle mouse button to rotate it. Let's add a cube, and I'm going to set this to have a size of 16 by 16 by 16. And just like that, we have our full block, but I'm going to make it slightly different. So I'm going to set the Y size to be 9, and I'm going to make the Z size 4. So as you can see over here, now we have a block, and this block is pointing north. And the thing that makes this block special is that we need to write a bit of code which will make sure that we can place this block in different directions. I'm going to create a texture with Ctrl-Shift-T, and this is going to be our template texture. We're going to also call this example block. Let's click confirm, and now we have a texture which we can edit in any program, or we can edit it by clicking on the paint tab. So I'm just going to paint on the block a little bit, just like so. And now that you've created your beautiful art, we can export it. But first we need to add a plugin. Let's go to File, Plugins, and search for Voxel Shape Generator for MCP and Mojang mapping. And let's click Install. Then let's click Close, and now we can start exporting. Let's go to File, export, and let's click block/item model. And I'm just going to save this as example-block.json. And then we want to go over here and we want to save the texture as example-block.png. And I'm going to overwrite the old one that I have. Next, we want to go to File, Export, and we want to export the voxel shape. And this is very important because we need to export it multiple times. And we want to always select Mojang mappings unless you've switched to MCP. Let's click Confirm, and we're going to name our voxel shape file. And this is going to be called North because the object is currently facing north. And now we've exported our model when it's facing north. Now what we want to do is position it in the south direction, and then we're going to once again go to File, Export, Voxel Shape, and we're going to call this South. We're going to click R and rotate it so that it's pointing to the side. And we're going to change the position from -16 to 0. And now you can see that it is pointing west. So let's File, Export, Voxel Shape, Confirm West. And then we're going to move it to the east. Like so. File, Export, Voxel Shape, Confirm East. Now let's go back into Eclipse. So let's create a new block, which is going to be our block that we can rotate. So let's create a public static final registry object of block. And this is going to be called rotating block. And this is going to be called rotatable block. And we're going to create a new register. This is going to take 3 things. So first we're going to give it the JSON name, which is just going to be rotatable block. Then we're going to give it the block and the item. And for the item, I'm just going to copy the same thing that we have up here, like so. And for the block, we're going to create a new block behavior.properties.copy, and we're going to copy the properties of a different block. So I'm going to use blocks.dirt. So this is going to have the same properties as dirt, and that means the same material and the same material color. Since we're using a custom model, we're going to set this to have a dynamic shape because it's not actually a full block, so the rendering will be handled differently. I'm also going to give it a sound type of soundType.stone. However, this block is going to need a custom class. So in our block package, let's create a new class called rotatable block. And once again, this extends block. Press Ctrl-Shift-O to import level.block.block. Hover over this, add the constructor, delete the to-do, rename the properties to properties, and the same down here. And then in our block init, we want to change this block to rotatable block and press Ctrl-Shift-O to import that. And there we go. Now we've added our rotatable block class. And up here, we're going to create a property. So let's create a public static final direction property. And this is going to be called facing. I'm going to set it equal to horizontal directional block dot facing. And this is a block property, which means we can change the block state and therefore block model and textures depending on what state our block is in. So we've just added the facing state. I'm also going to add an example functionality where my block can be toggled to have light level on and off. So I'm going to set the public static final boolean property, and this is going to be called lit, and we're going to set it equal to boolean property.create, and we're going to give it a name of the property, so lit. There's lots of different properties that exist, and all of them will be slightly different in this line here, and maybe later on, but I'm just going to use these 2 default ones to demonstrate how they work. Next, we're going to overwrite create block state definition, and we're going to change this to builder. And instead of the to-do, we're going to do builder.add, and we're going to give it a list of properties. So I'm going to do facing and lit. And now our block state will contain the facing and lit properties, and you want to make sure to add all your properties to the block state definition. Next, in our constructor, we need to set the default state. So let's do this dot register default state, and then we're going to do this dot default block state dot set value, and then we're going to give a property, so facing, and then we're going to set direction dot north to be the way that it faces. And we want to make sure that the direction is net.minecraft.core.direction. We're also going to set value lit to be false. and this is just going to make sure that the block is not lit by default. Next, let's add the voxel shapes that we exported. So if we open up the text file, you can see that we have this voxel shape. Then we set shape equal to all of this. And we're just going to copy the bit inside here, which has voxelshapes.box. So we're going to copy that, and under this, we're going to set public static final voxel shape north is equal to, and then paste. Let's press Ctrl-Shift-O to import both of those, and we're going to change voxel shapes to just block. Then I'm going to copy and paste this start bit 4 times for east, south, and west. And then I'm going to repeat opening the text files, copying this segment of the code, and pasting it, adding a semicolon, replacing voxel shapes with block, and then repeating the next one. Those are the 4 voxel shapes in different directions. Next, we're going to override getShape, and for this we get a block state and we need to return the correct voxel shape that we can use. And since we're actually putting decimals in here, we need to replace blocks with shapes, like so. There we go. Next, we're going to rename some of the parameters we get here. So let's rename this to state, this to getter, this dot pos, and this to context. Then we're going to write a switch statement for state.getValue for facing. Then we're going to hold this and we're going to add missing case statements. And then we want to delete these statements for up and down. For east, we're going to return east. For north, we're going to return north. For south, we're going to return south, and for west, we're going to return west. And this will select the voxel shape for each direction. And we're just going to set the default voxel shape to also be north. And that means we can actually delete this case north, since that will just revert it to the default. And there we go. Now we're selecting our voxel shape. Next, we need to make sure to correctly rotate the block when it's placed in the world. So we're going to go down here and override getState for placement. And this is just going to take a context. Let's replace that. And in the to-do, we're going to return something that isn't the super. We're going to return this.defaultBlockState.setValueFacing, and in here we're going to do context.getHorizontalDirection.getOpposite, which is going to set the correct position when it's placed. Finally, let's overwrite 2 more functions. We're going to overwrite mirror, which is going to take a state and a mirror, and we're going to return state.rotate, and this is going to take a rotation, and that rotation is going to be mirror.getRotation for state.getValueFacing. And we're going to make sure to suppress warnings for deprecation. Next, we want to override rotate, and we want to make sure to overwrite the one that has 4 arguments passed in. So the state, world, pos, and direction. And we're going to return state.setValueFacing to direction.rotate for state.getValue for facing. And this is going to apply rotation to our block. And that is actually it for our rotation code. Next, let's add some code for our lit. And we're going to copy some of the stuff we wrote over here. So let's just select all of this, press Ctrl-C, and paste it down here into our block. And what we're going to do is, when it is used, if it's right-clicked with a diamond, we're going to toggle the lit state. And we're going to do state.setValue. So we're going to set lit to the opposite of what lit currently is. So not state.getValue lit. And then we actually need to change the block if it is lit. So after properties, we can also add stuff to our properties inside our block. And since we need the lit thing over here, I'm going to add the light level in our block class instead of the block in it. And in the light level function, we get given a state, and with it we need to output an integer. So what we're going to do, we're going to output, so return, and we're going to return 15 if it's lit. So let's do state.getValue lit, and this is going to return a boolean, and if it is lit, we're going to return 15, and if it isn't lit, we're going to return 0. Next, we're going to need to create a custom block state. So in source main resources, let's go to assets.tutorialmod.blockstates and create a new Blockstate, new file called rotatable block.json. And for now, let's copy over our example block. And let's change the model to rotatable block. However, as you can see, here we have something for all variants, and this isn't possible when we have a rotatable block or any block with properties. So here we have two properties, facing and lit. And if we open facing, you can see that the name for facing is actually just facing. And the name for the boolean is the one we created here, so the name for the boolean is lit. And that's going to be important when we write our block state. And what we're going to do is create variants for facing equals north, facing is south, east, and west. We need to make sure to have all the possible values. We also need to include lit, even though we're not changing the model. So let's say lit is true and facing is north. Then we're going to use this model. Then let's copy and paste that 3 times, changing the north to east, south, and west. And despite the fact that we're going to be using the same model, we're also going to rotate the model when we're using it. We're going to rotate all of them on the y-axis, so we're going to add comma, y, and then the rotation in degrees. And I don't actually know what this rotation is going to be, so I'm going to guess, and then we're going to adjust it afterwards. For now, I'm going to put this to 90, this to 180, and this to 270. So that's 1 right angle rotation, 2 right angle rotations, and 3 right angle rotation. And then I'm actually going to copy all of this, add a comma, and then paste it, and we're going to select all the ones that are highlighted and press Ctrl F. We're going to make sure the scope is on selected lines, and then we're going to replace true with false. Click replace all, and there we go. Now that we have the exact same models when the state is false. Now we actually need to create this rotatable block model. So let's go to models block, and in here let's create a new file called rotatable block. And now if we open the example block.json that we exported before, we can select all of this and paste it in here. And we actually forgot to name this a JSON, so I'm going to quickly rename that now. Here we have the credits, you can change this to whatever you want, the texture size, and the textures. And since we are using our own textures, we need to add our tutorial mod : and this isn't example block, this is rotatable block. And we're going to copy this and paste it for the particle as well, since we want to use the same texture there. Something I didn't mention during Blockbench is that this item will display weirdly in the inventory. To fix that, you can go to display and manually set the display stuff or use a preset. I'm going to use a preset, so I'm going to go over here to apply preset, and we're going to select default block and apply to all slots. And now this will behave in an inventory just like a default block. We can re-export the block model, but this won't change any other aspects of the model. So now that I have this re-exported model, I'm going to copy and paste it, and then redo the textures like I did before. Now we need to drag our texture into the block class. So here I have the example block.png. So let's rename that to rotatable block.png and then drag it into the textures.block package. Let's go to our lang and quickly add that like so. So this is our rotatable block, and let's rename this to rotatable block as well. And I'm not going to make any tags because I don't care that much about the block, but now we can start the game and see what happens. And when we load in, I forgot to create the item model for the block, so we'll do that in a second. And you can also see that every time we place the block, it's rotated by 90 degrees. So we need to fix that. In our block.item, we're just going to copy the example block and paste it and rename it to rotatable block. And inside there, we're going to change the parent to rotatable block again. And in our model file, we're going to offset each one by 90 degrees. And when we have 270, we're just going to put 0, not 360, like so. Now if we go into the game and press F3 and T, it's going to refresh all the assets that are in our package. You can see that we now have the item models, but now we rotated the things the wrong way. So I'm going to put those back. That means the first one has to be 270, the second one is going to be 0, the third one is 90, and the last one is 180. And now if we press F3 and T again, we can see that our block is properly rotated and has the hitbox. And what we wrote before in the use function wasn't actually setting the block state. So to fix that, what we're going to do is world.setBlock. We're going to give it the position, a state, and then 4. And then we're going to change the state to cycle lit. And what this is going to do is swap the state of lit and then set that in the world. And now in our game, we can see that if we right click on our block with a diamond, we can see that it toggles between emitting light and not emitting any light. Next, we're going to talk about render types. And this is pretty much always used when we make a custom model. So let's right click on our main package. Let's go to create a new package. This is going to be called client. And in here, we're going to add a new class called client event bus subscriber. And at the top, we're going to type at mod.eventBusSubscriber. We're going to open brackets. We're going to set the mod ID to tutorialmod.modID. We're going to set the bus equal to bus.mod. And we're going to set the value equal to dist.client. Let's press Ctrl-Shift-O to import everything. And now in here, we need to add an at subscribe event. And this is going to be a public static void called client setup, which is going to take an FML client setup event. And in here we're going to set up everything that's to do with the client. So all we need to do to add a render layer is to do item block render types dot set render layer. Then we give a block, so we can do block init dot rotatable block dot get, and then we can set the render layer. So let's do render type dot, and these are all the different render types that we have. I'm just going to select cutout, which is a simple custom model, but you can select anything you want. You can also hover over item block render types, and in here you can see what each Minecraft item and block uses by default. And that's it for our render types. We'll also need this class later when we do a bunch of other client-related things. Next, we're going to go over some more item-related things, specifically how to make foods and fuels. In order to create a fuel, we need to overwrite a method inside the item class. So in our example item class, let's create a new method, which is going to be called getBurnTime. And by default, this is going to be -1, which means it doesn't burn. But we can do something like return 1000, which is how many ticks this is going to burn for. Remember that there are 20 seconds per tick, so 1000 ticks is equal to 1000 divided by 20 seconds. That's 50 seconds. So this is going to burn for 50 seconds. And that's it. Now our item is a fuel. Another thing we can do is make our item a food. And in order to make it a food, we need to add a property in our item in it. And this property is called .food. So let's create a new food properties.builder. And in here we need to add stuff to our food. Let's put .build at the end. And this is going to actually return the build. And in between the builder and .build, we can add all the properties for our food. We can set always eat so that you can always eat it. Effects, which I'll cover in a second. We can make it a meat. We can give it a nutrition value, a saturation value, and you can make it be fast to eat. Once again, you can find all the hunger and saturation values on the Minecraft wiki, but for the nutrition or hunger, I'm going to put 4, so 4 half bars, that's 2 like full bars of food. And then saturation, which is how quickly you'll regenerate after, I'm going to set that to 2.0. If we want to make this food give an effect, you can do .effect, and then we give a supplier of a mob effect instance and a probability that this effect will be given. I'm going to say that we're going to give a 100% probability of giving a new mob effect instance, and then we're going to create a mob effect instance. Next we need a mob effects. Let's do mob effects dot regeneration. Next we have the time in ticks. So let's do 200 ticks, which is 10 seconds. Once again, divide by 20. And then finally the strength. Remember that 0 is level 1 regeneration and 1 is level 2 regeneration. So I'm going to put this to 0, which is going to give us regeneration 1 for 200 ticks with a 100% probability. And if we load into the game, you can see that our example item can now be used as fuel, and it will smelt items for 50 seconds before eventually running out. We can also eat the item now, and it's going to give us regeneration for 10 seconds. And it will regenerate 4 hunger bars and a couple of saturation bars as well. Next, let's do some tags and some recipes. And information for most of this stuff can actually be found on the Minecraft wiki, but we're going to do a little bit anyway. We already covered overwriting default Minecraft tags last time with the replace values and adding values ourselves. We can also create our own tags. And this is very similar to before. We can go to tutorial mod and create a new package, and let's call this data.tutorialmods.tags.blocks. And this is how we make block tags. You can do the exact same thing for item tags if you'd like to. Let's create a new file called cool_blocks.json. And in here, this is going to be very similar to what we had before. So we're going to do replace, and we're going to set that equal to false. And then we're going to add our values. And inside these square brackets, we're going to put the registry IDs of all the cool blocks. So tutorialmod::block/example block, that's a pretty cool block. And another cool block is actually Minecraft::block/diamond_ore. So now we're adding our example block and a default Minecraft block to a list of cool blocks. And if you want to access this tag through code, we're going to need a new init class. So let's create a new class called tag_init, and this class is actually a final class. So let's create a public static final class inside the class, and this is going to be called blocks, and this is going to have all our block tags. And then let's do the exact same thing for items. So public static final class items. In here, let's create a private static tag.named, and this is going to be of block, and we're going to call this mod, and this is going to take a string path. And in here, we're going to return block tags.bind and a string, which is actually going to be a new resource location of tutorialmod.modID, then the path, and then .toString. Next, let's copy paste this into the items class over here. Change this block to item, and change this to item tags. Next, let's register our tag. So public static final tag.named block. I'm going to call this cool blocks is equal to mod, and the name of the tag is cool_blocks. Now let's create an item tag. So in our tags package, let's delete the blocks and create a new package called items. And you want to make sure that this is plural, so it has the S at the end. And let's add a new tag called cool_items.json. And once again, we want to set replace to be false, and then we want to set values to a list of all the cool items. I think a cool item is tutorialmod::example item and Minecraft::diamond. And one thing we did wrong in the blocks is that we don't need this block slash, it will automatically look for block. In our tag init, let's now create a public static final tag.named of item. This is going to be called cool_items equals mod of cool items. Next, let's use these tags somewhere. Right now, to switch the light level on our rotatable block, we're checking if it's a diamond. So instead of all of that, we're going to write tag_init .items, since we're looking for items, cool items.contains, and now we need the item, so player.get items in hand, so we're going to get the held item, but this is an item stack, so we need the item from the item stack. And there we go, now we can use two different items to toggle our block. So now if we run the game, now you can see that to enable the light level on our block, we can use both a diamond and our example item. Next, let's cover some recipes. And to create a recipe, the only thing we need is a JSON file. Once again, since this is going to be part of a data pack, all of the information for this can also be found on the Minecraft wiki. In our tutorial mod package, let's create a new package called .recipes. And in here, we're going to add all our recipes. So I'm going to create a recipe for all of our stuff. So let's create a new recipe, and this is going to be how we craft our example block. And the way we do that is going to be by crafting 9 example items together. So we're going to set the type to be crafting shaped, since this is a shaped recipe. And then we need the pattern. And the pattern is going to be 3 different strings. Think of these strings as your crafting table. And to put items into that crafting table, we need letters. So if our recipe is going to be a 3x3 recipe, we're going to have 3 rows, and we're going to say, look, we want to craft 9 of our items together. So let's say our item is I. You can fill this with I, just like a crafting recipe. If you want to have no item here, we can put a space, and then we'll have 8 items. If you only want to craft 6 items together, we can have 1 row like that, and then you can put this at the top or at the bottom of your crafting table. Same thing with this. If we have 4, you can put this in any place in your crafting table as long as 4 slots are occupied in this pattern. If you want multiple different items, you need to use different letters for each item. Let's say I want to surround item B with item I, then I'd put item B in the middle and put item I everywhere else. I'm just going to leave this as them all being I. However, Minecraft doesn't actually know what I means, so we have to tell it what it means. So to do that, we have a key. And in this key, we're going to define I is going to be equal to something. And in here, we can either say something like an item, so this is going to be tutorial mod example item, or we can set it to a tag. So you put a tag, something like tutorial mod cool items. So let's do that. So now any cool item in a 9x9 grid will give our output. But now we actually need to define what the output is. So then let's set the result, and the result is always going to be an item, which is going to be tutorial mod example block, and we are going to output only one of those. Let's add the missing comma, and that is our shaped recipe done. Now let's add a shaped recipe for crafting this example block back into our cool items. However, over here you can see that we actually have a recipe conflict because the cool items will include diamonds, and as we know, 9 diamonds in a grid is going to give us a diamond block. So I'm actually going to remove this to be 8, like so. That way we don't have any conflicting recipes. I'm now going to add a new recipe called example item.json, and this time we're going to use type is equal to crafting shapeless, and this is going to be slightly different. You need a list of ingredients, so let's do ingredients is a list, and to add an ingredient we can do something like that, and once again in here we can do a tag and then the name of a tag, or we can do an item. I'm just going to do an item for this one, so I'm going to do tutorial mod example block, so that's the item that's going into the recipe, and we only need one of these in any position. If you add more ingredients, so something like this, that just means you need 3 example blocks in any position. Or something like rotatable block means that you need 2 example blocks and 1 rotatable block in any position in the crafting table, and that will give you the output. But I'm just going to stick to 1 example block. And now we just need the result, which is going to be an item of tutorial mod example item, and I'm going to output 8 of them. So count is 8. And there we go. And we want to make sure to put Minecraft : before each of the names of the types, so that we know we're using a default Minecraft type. I'm going to quickly cover smelting recipes as well, and if you want to see more different recipe types, you can always go on the Minecraft wiki. So let's create a rotatable block.json file, and this is going to have a type of smelting. So now that we have Minecraft : smelting, we're going to need our ingredient, and this isn't going to be a list, this is just going to be one thing, and we're just going to use an example block as the single ingredient. As always, you can use a tag here instead. Next, we're going to add a result, but this time we don't need a count, so this is just going to be on one line. So let's do tutorial mod rotatable block. But for a furnace, we actually need a couple more things. We need experience, which is the amount of experience given. I'm going to set that to 0.2. And we need the cooking time in ticks, which is how long it's going to take to smelt the item. I'm just going to put 200 ticks. And that is our smelting recipe. Now we can start the game. So in a crafting table, we can craft any 8 cool items together, and we can even mix and match them. So I'm going to craft 8 diamonds together in this kind of pattern, and this is going to give me an example block, which can then be crafted down into 8 example items, and these can be crafted back into example blocks. And if we go over here and we smelt them, you can see that after a while we get a rotatable block as an output, which can be turned on and off with our example item, which can also be eaten for some reason. And that is going to do it for this episode. If you need any help, join the Discord, and there are links to the Discord, the source code for this video, and any useful links in the description. In the next episode, we're going to be covering data generators so that you can automate the JSONs in your project. Thank you for watching, and I'll see you next time. This was a really long episode.